Ladies and gentlemen, welcome to the English Daily Book Summary YouTube channel. In order to not stop learning, listen to an English book summary every day for free.
Stephen R. Gundry, The Gut-Brain Paradox: Boost Mood, Clear Brain Fog, and Reverse Disease with Your Gut. Modern science is radically rethinking what it means to have a healthy mind. We've long been told that mental clarity, emotional balance, and cognitive resilience depend on brain chemistry, personal habits, or inherited traits. But a growing body of research points to something deeper, an internal system that's been shaping human behavior for millennia, operating largely outside conscious awareness. That system is your microbiome. It's made up of trillions of bacteria, most of which live in your digestive tract. They support digestion, yes, but they also influence immune responses, hormone production, and the way your body processes stress, motivation, and reward. And when that system shifts, so does your experience of daily life. In this blink, you'll learn how these tiny organisms in your gut impact everything from appetite and addiction to mood and memory. You'll see how their signals help guide brain development, mental health, and aging, and what that means for the way we eat, think, and live. Let's get started by understanding just how much control your microbiome already has. Your gut shapes your mind more than you think. Half the cells in your body are microbial, and the majority of them live in your gut. This internal ecosystem, known as the gut microbiome, includes trillions of bacteria from thousands of species. They interact with nearly every system in the body and play a key role in regulating inflammation, hormone levels, and the immune response. What's now becoming clear is that this microbial population also plays a central role in shaping how the brain functions. The gut is directly connected to the brain through the vagus nerve, a thick bundle of fibers that carries more signals upward from the gut than downward from the brain. Microbes influence these signals by producing postbiotics, chemical compounds created during digestion that behave like neurotransmitters. These include dopamine, serotonin, and GABA, which help regulate emotional stability, mental energy, and stress sensitivity. Postbiotics also influence the permeability of the gut wall and the behavior of immune cells, which affects inflammation levels throughout the body. When the microbiome is healthy, these signals support mental clarity, focus, and emotional balance. But when the microbial balance breaks down through diet, antibiotics, stress, or environmental toxins, the signaling patterns change. Certain bacterial strains may dominate because they thrive on sugars or processed fats. These microbes can promote cravings for the substances that help them multiply. They may also stimulate the release of stress hormones or interfere with the body's normal satiety signals, leading to cycles of anxiety, impulsivity, and poor concentration. Some species have even been linked to personality traits. Higher levels of specific bacteria correlate with increased neuroticism, irritability, and compulsive behavior. Experiments in mice show that altering the microbiome can change mood, social behavior, and even brain structure. The influence of gut microbes is widespread and often hidden. To understand your thoughts and decisions, it's worth considering the signals coming from your gut. In the next section, you'll learn how those signals guide eating habits, appetite, and the feeling of satisfaction after meals. Your cravings aren't coming from you. Many people think of hunger as a simple response to the body's energy needs, but your sense of hunger, your cravings, and even your food preferences are being shaped by organisms that aren't you. The bacteria in your gut are deeply involved in deciding when you feel hungry, what you want to eat, and how satisfied you feel after eating. And those decisions often reflect what the microbes need, but not what your body requires. These microbial priorities are, in fact, a direct consequence of the microbiome's composition. It's a diverse community where different bacterial species rely on specific nutrients to survive. Some flourish on sugar and processed fats, while others thrive on fiber or resistant starches. When one group gains an advantage, it begins to influence chemical signaling to maintain control. Certain bacteria release metabolites that activate hunger hormones or stimulate the release of dopamine after eating high-sugar foods. Others slow the signaling that normally tells the brain you've had enough. The result is a shift in appetite regulation that serves the microbes' growth more than your long-term health. This microbial manipulation plays out in subtle but measurable ways. People with imbalanced microbiomes often feel hungrier shortly after eating. They may experience more frequent cravings for ultra-processed foods, which directly feed the strains of bacteria that are dominating. The feeling of satisfaction becomes harder to reach, and the cycle of eating and craving becomes harder to break. This pattern is biochemical. The gut is sending signals that bypass conscious control. Some studies have even shown that transplanting gut bacteria from overweight individuals into lean ones can increase hunger and weight gain in the recipient. These findings point to a more complex explanation for metabolic disorders than willpower or calorie counting. The microbiome is playing an active role in driving overeating and food addiction. Understanding hunger as a shared process between you and your microbes helps explain why some efforts to change eating habits feel like an uphill battle. In the next section, you'll explore what makes certain bacteria more dangerous than others, and how the smallest doses of their byproducts can reshape brain function over time. Tiny toxins can train or damage the brain. Small doses of bacterial toxins might seem irrelevant to brain health, but they can have surprisingly large effects. One of the most powerful examples is lipopolysaccharide, or LPS, a molecule found on the outer walls of certain bacteria. When LPS leaks into the bloodstream in low amounts, its effect is to generate a slow, steady wave of inflammation that can disrupt systems across the body, including the brain. This kind of exposure, sometimes called subclinical or chronic inflammation, can alter the way the immune system responds over time. You see, the body stays in a state of low alert, which leads to subtle but persistent changes in how neurons communicate and how mental energy is regulated. LPS and other microbial byproducts can reach the brain and activate microglia, the immune cells of the central nervous system. When microglia are overstimulated, they shift from their normal housekeeping role into a reactive state, releasing inflammatory compounds that interfere with brain function and increase the risk of cognitive decline. What makes this process harder to detect is the effects aren't immediate. People may feel more tired, irritable, or forgetful without realizing that these changes are tied to a chronic internal immune response. Over time, this pattern contributes to brain fog, mood instability, and in some cases, to conditions like Alzheimer's and Parkinson's. Ironically, very small doses of certain bacterial components can also have the opposite effect. They can help train the immune system to tolerate microbial signals instead of overreacting. This helps explain why traditional diets rich in fermented foods, beans, and rough fibers, once considered risky for digestion, actually help support mental and emotional stability. These foods feed the right microbes and produce just enough microbial material to keep the immune system balanced rather than inflamed. Understanding how microbial byproducts influence the brain reveals how delicate the immune microbiome relationship really is. In the next section, you'll see what happens when this relationship is thrown completely off course, especially in cases where microbial signals start reinforcing full-blown addiction. Addiction is a microbiome survival strategy. Addictive behavior may look like a failure of willpower, but what's happening under the surface tells a more complicated story. The microbiome plays a major role in shaping habits, cravings, and even dependency. Certain microbes benefit directly from addictive substances, and they've evolved ways to keep the host coming back for more. One key way these microbes exert their influence begins inside the gut. Some bacterial strains respond to alcohol, opioids, or nicotine as if these were food sources. These substances can help specific microbes grow, giving them a competitive edge. As they multiply, they influence the chemical messages sent to the brain. Specifically, these microbial signals can increase stress, heighten reward seeking, or reinforce cravings. In effect, the microbiome begins to push behaviors that favor its own survival. Over time, this creates a feedback loop. The more the host uses the substance, the more the microbiome shifts in favor of bacteria that depend on it. The evidence supporting this microbial role in addiction is growing. For instance, animal studies show that altering the microbiome can change how much a subject seeks out addictive substances. In some cases, transplanting gut bacteria from addicted individuals into non-addicted ones led to increased substance-seeking behavior in the recipient. This suggests the microbial balance itself can create or amplify the drive to use. Furthermore, findings from human studies have also linked dysbiosis, an unhealthy shift in microbial composition, to increased anxiety, impulsivity, and loss of control. These traits that are common in addiction but often misunderstood as purely psychological. And these microbial effects extend beyond behavior. They also shape the immune system and hormone production, which can raise inflammation and alter how the brain processes reward and punishment. In a brain already exposed to addictive triggers, that shift makes recovery more difficult. Withdrawal symptoms can be partly driven by microbial stress signals when the substances they rely on are suddenly removed. Understanding addiction through the lens of the microbiome opens the door to new strategies for prevention and treatment, ones that address the underlying microbial signals rather than just the visible symptoms. In the next section, you'll look more closely at how microbial disruption is connected to other common mental health diagnoses like anxiety, depression, and eating disorders. Mental health disorders reflect microbial imbalance. So far, we've touched on how microbial imbalances can influence traits like anxiety and patterns related to disordered eating. We now delve deeper into how these disruptions manifest in formally diagnosed mental health conditions such as anxiety, depression, and eating disorders. To truly understand these conditions, it's vital to understand the specific microbial shifts involved and their direct impact on emotional regulation, cognitive resilience, and the brain's stress responses. In the case of diagnosed mood disorders, for example, researchers consistently find reduced microbial diversity along with an overgrowth of inflammatory species. These shifts are associated with increased intestinal permeability and chronic low-grade inflammation, factors that interfere with the way the brain regulates mood and focus. For instance, decreased populations of certain short-chain fatty acid producers are often observed in people with depression. These beneficial microbes help reduce inflammation and support the barrier between the gut and bloodstream. When they're missing, the body becomes more vulnerable to immune disruptions that can affect the brain. The microbiome also influences how the brain handles neurotransmitters. Gut bacteria produce or modulate levels of serotonin, dopamine, and GABA, key chemicals involved in emotional balance, motivation, and calm. If the wrong microbes dominate, the production and regulation of these compounds shifts, creating symptoms that match classical psychological conditions. This has been shown in both human studies and animal models where microbiome changes led to measurable differences in anxiety-like or depressive behaviors. Eating disorders present a particularly strong example of microbiome behavior interaction. Starvation and binge cycles dramatically reshape the gut environment, and the resulting microbial shifts then reinforce those behaviors. Some species begin to signal the brain in ways that either suppress or exaggerate appetite cues, intensifying the extremes. Mental health is increasingly being understood as a two-way street between the brain and gut. Therapy and medication can play an important role, but without addressing the microbial environment, many of these conditions remain difficult to treat. In the final section, you'll see how long-term brain aging and neurodegenerative disease also track back to the health of the microbiome. Brain aging begins in the gut. Long before memory loss becomes obvious or motor issues appear, subtle changes are already taking place in the brain. These early shifts in function are increasingly being traced back to the gut. The process known as neuroinflammaging, the chronic, low-grade inflammation that accelerates brain aging, often begins with disruptions in the microbiome. As the gut microbiome loses diversity with age, the balance of immune signals changes. Protective bacteria decline, while others that promote inflammation start to dominate. This shift weakens the gut barrier, allowing microbial fragments to pass into the bloodstream. The immune system reacts, activating inflammatory pathways that reach the brain and trigger the release of molecules that damage neurons over time. And one of the key effects is the overactivation of microglia, the brain's resident immune cells. When these cells stay in a hyperalert state, they begin to attack healthy tissue and interfere with normal brain repair processes. Specific microbial signals have also been linked to the buildup of abnormal proteins in the brain. Bacterial amyloids, which are molecules made by gut microbes, share structural similarities with the amyloid plaques seen in conditions like Alzheimer's. These proteins may cross-react with brain tissue or confuse the body's cleanup mechanisms, accelerating neurodegeneration. Researchers have found that even in early stages of cognitive decline, people often show signs of microbial imbalance and increased gut permeability. Lifestyle factors that support microbiome diversity, such as high-fiber diets, polyphenol-rich foods like coffee, dark chocolate, olives, and berries, and intermittent fasting, all show protective effects on brain aging. These habits promote the growth of bacteria that produce short-chain fatty acids, compounds that help reduce inflammation and protect neural function. Supporting the gut is becoming a core part of understanding how the brain ages and what can be done to protect it. The connection between gut microbes and mental health runs deeper than previously imagined. From cravings to cognition to chronic disease, the microbiome plays a shaping role. By supporting this hidden ecosystem, we gain a powerful lever to influence how the brain feels, functions, and ages across a lifetime. The main takeaway of this blink to the gut-brain paradox by Stephen R. Gundry is that your gut microbiome plays a central role in shaping your mental and neurological health. Microbes in your digestive system influence far more than digestion. They affect how you feel, how clearly you think, what you crave, and how your brain ages. These microbial signals help regulate appetite, guide mood, contribute to addiction, and even play a role in depression, anxiety, and cognitive decline. Disruptions in the gut ecosystem can lead to inflammation and changes in brain chemistry that impact everyday functioning and long-term well-being. By understanding the microbiome's influence on your brain, you gain new tools for improving mental clarity, emotional balance, and resilience. The science is still evolving, but the message is clear. If you want to think better, feel better, and age better, your gut is a good place to start. Okay, that's it for this Blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next Blink.